Hello, welcome back to Algebra 1. In the last section, we introduced the concept of an exponent. We taught you what an exponent was, which is the most basic thing you can learn about them. Now, we're going to learn how to handle exponents in terms of this thing called order of operations. If you remember, a long time ago, we taught you how to do multiplication and division and parentheses in the order in which you have to do everything in algebra. And here we're just going to add one more item into that list because now you know about exponents, so we need to teach you when you need to do your exponents in terms of order of operations. So we're just going to write down order of operations. And I'm going to write down here with exponents, because now we have introduced the concept of an exponent, okay? So, long time ago we talked about this, but we didn't know what an exponent was. Now we do. So the first thing you do is the first thing that you always, nothing has changed. The top most important priority that you do is you do the parentheses or brackets, whatever was written down. You always do those first, inner to outer. Okay, which means if you have multiple sets of parentheses and they're nested inside of one another, you always go and do the innermost ones first, and then you work your way to the most outermost one. So that's the number one thing you do. Now, what I'm adding here, so that's number one. Number two, right after parentheses comes your exponent. So you do your exponents. And this is new because this was not in what we have learned in the past. Number three, you're going to do what we've learned before, multiplication. I'm going to put that as an X, and division. I'll put that as a division symbol. We do that left to right. Just like you're reading a sentence, left to right, multiplication and division. And the very last priority, the least important thing to do, you always do it last, addition and subtraction. Again, left to right. I'm writing it down for you here on the board in real time because I want you to I want it to sink in. The only thing different that we've added to this list is the exponents here. What I've taught you in the past is to do the parentheses first, inner to outer, then do multiplication left to right along with division left to right, and then do adding and subtracting left to right. So 1, 3, and 4 were what we have talked about in the past. Now that you know about exponents, they come right after the parentheses. You always do those next. So I'm going to leave this on the board. We'll kind of draw a little line here. We'll leave it here. And we will do problems, and we'll refer to this as we go. And as you'll find out, it's not going to be hard to memorize these because you're going to work so many of them. So let's just start out by doing some very simple things with exponents. What if we have A times B times B times B? So now we have the variable A multiplied by itself twice and the variable B multiplied by itself 3 times. How do we write that as an exponent? Well, you write it as A squared, because that's multiplied by itself twice, times B cubed, and you write that down as B to the power of 3 because it's multiplied by itself 3 times. You don't need to put a multiplication symbol in the middle because it's understood that when you write two variables next to each other, it automatically means multiplication. Now you can also write this as B cubed A squared. It's the same exact thing, because they're multiplied together. So whether, 3 times 4 is the same as 4 times 3. So A squared times B cubed is the same thing as B cubed times A squared. You flip the order, it doesn't matter for multiplication. So this is the answer I would typically circle, but this is perfectly fine if you want to write it backwards. It's all right, no problem. All right, what if we had X times Y times X times X? How would we write that? Well, the variable x, see, everything's multiplied here. So the variable x is multiplied by itself 3 times. So I would write that as x to the power of 3. But y is also multiplied by all that stuff, so I would write multiplication times y right there. And that would be my final answer. Now, I could also write this as y times x cubed. I could do that if I wanted to. In fact, let me make that a little bit clearer. I could write that as y times x cubed. That'd be fine. Just flipping it around doesn't make any difference, but typically you would just write it like this, no problem. Now what if we had r times negative 3 times s times s? r times negative 3 times s times s. Now the negative 3 is just a number. It's not multiplied by itself or anything like that. So we always write our numbers first. And you have a couple of things you could do here. The r is not multiplied by itself, so it's just going to be multiplied by r. But we have s here multiplied by itself 2 times, so it'll be s squared. So that's how you would write it. Now you can write it, differently if you want. You could say negative 3s squared r. You could write it like that, no problem. You can flip it all around, but the number, the negative 3, is always going to be in the front. That's always going to be written like that. But the variables, doesn't really matter the order in which you write them, as long as you get the exponent correct. S squared is the thing that has the exponent. All right, so let's switch to a slightly different kind of problem. Let's ask you, what if you had negative 2 to the power of 2? How would you solve that, or how would you simplify that? Well, you can follow your order of operations, but for such a simple problem, you're going to do the inside of the parentheses first, but inside of here is just a number. There's nothing to do. So then the next thing you do is exponents. Now you have an exponent, so you have to handle that. And so what you really have here is this is negative 2 multiplied by negative 2. Make sure that you understand that this squared is just this number multiplied by itself 2 times. Now what is negative 2 times negative 2? 2 times 2 is 4, and negative times negative is positive, so this actually is a positive 4. So that's how you would solve that problem. Now let's take something slightly different. What if you had, now this is where people get really tripped up, what if you have negative 2 squared? Doesn't this look like the same thing? Well, you see here, the parentheses make it very clear that I'm taking everything inside and multiplying it by itself 2 times. So the negative 2 times the negative 2. But when you write it like this with no parentheses, what you really are saying is that it's like negative 2 times 2. That's what you're really saying there. And since 2 times 2 is 4, then what you end up with in this case is negative 4. So if you actually look and type this into a computer or something with no parentheses like this, it's going to return negative 4. But when you put the parentheses and then square it, it's going to give you positive 4. And that's because when you don't put in parentheses, the square is applying just to the 2. And the 2 is what's getting squared. The negative sign is just hanging out in front, and that makes it negative 4. So if you're really trying to square negative 2 all together, you have to put those parentheses there to make 100% sure that everybody understands what you're doing. So keep that in mind. All right, now what if you had something like negative 4 squared times 3? Same thing. Don't get tripped up in what this means, okay? The negative 4 squared, I don't have any parentheses here. But look at my order of operations. First, I'm looking for parentheses. I don't have any parentheses. Then I do my exponents. And after I've done my exponents, then I can do multiplication. So this multiplication that's here, that comes later. I must do the exponent first. That's what the order of operations is really telling me. All right? And here, it's negative 4 squared, which is really like negative 4 times 4. The negative is just kind of hanging out there, 4 times 4. And then you have multiplied by 3. So what you have is negative 16 times 3. The negative 16 is this. The 4 times 4 gives you the 16. The negative is just hanging out there. It's not squared. The square here does not apply to the negative that's out in front because there's no parentheses there. So it's going to just apply to the 4. The negative just hangs out there. So you have negative 16 times 3. And negative 16 times 3 is negative 48. Because 16 times 3 is 48, negative times positive gives you negative. So make sure you understand that. Whenever you have a squared object and there's like a negative sign there, there's no parentheses, you just apply it to the thing that's right there. You don't apply it to this unless it's wrapped up in a parentheses, then you're absolutely supposed to apply to both. Last problem for this quick little section is going to be 3 times 4 minus 5 squared. So what do? We first look for parentheses. That's the first thing we need to do, inner to outer. So you see we have the parentheses. We have to do that first. So let's rewrite everything. 3 times. What is 4 minus 5? 4 minus 5 is negative 1 because 5 minus 4 is 1 and the sign of it goes with the larger absolute value. And you still have this quantity squared. Now you see how in this case inside the parentheses, which I've already done now, is negative 1, and that whole quantity is squared. So the exponent applies to everything inside of this. So this is negative 1 times negative 1. What is negative 1 times negative 1? Is positive 1. Negative 1 times negative 1. Negative times negative is positive, so that gives you a positive 1, and then 3 times 1 is 3. And that's the final answer. And I lied. I actually have one more problem. Let's work it very slightly differently. What if we had 3 times 4 minus 5 squared? You see how the numbers are the same? This problem is exactly the same as this one. Here we just had parentheses to force us to do it this way. Now we're doing exactly the same thing, but there's no parentheses here. Now how does it change the problem? First we look at order of operations. There's no parentheses here. So the next thing we do is exponents. So here we have the 5 squared. This negative sign is not squared. It's not part of the squaring operation because there's no parentheses anywhere. The square only applies to this number below because there's no parentheses. So what you end up with here is 3 times 4 minus, what's 5 times 5, or 5 squared? 5 times 5 is 25. All right, and then you look at your order of operations. I've done my parentheses. I've done my exponents. Now I do multiplication and division left to right. So I have a multiplication here that comes before that subtraction. So 3 times 4 is 12, and then I have minus 25. There's only one thing left to do, and that is the subtraction. What is 12 minus 25? You handle it by subtracting. 25 minus 12 is 13, and the sign goes with the large or absolute value, which is negative. So you get negative 13, and that's the final answer. The reason I'm doing these is because if you look at this problem, it's the same numbers and the same exponent, but I get negative 13 here. Same numbers, same exponent, I get a totally different answer. The only difference is the parentheses forces me to do things in a slightly different order. And so if you have parentheses, you might get a different answer than if there's none there. So order of operations is really important in algebra is the point here. Make sure you understand these, and then follow me on to the next lesson. We'll do a bunch of other problems to give you practice with this order of operations concept now that we know about exponents in algebra.